Um, okay, well, this video is intended for anyone that needs help with math in general, but because I teach Algebra 1, I'm just going to do some quadratic functions while we wait for questions, just to review stuff that people need to know. So, so when you have equations like this, which I will say usually it says like equals y, you want to graph them. This is standard form for quadratic equations. And so when you're graphing standard form with quadratic equations, you have to find your axis of symmetry first. And that axis of symmetry is when you do negative b over 2a. And so remember when you did the quadratic formula, probably in other or previously, your a is the number in front of the x squared, which is 1. Your b is in front of the x, which is -4 in this case, and your c is that constant number that doesn't have a variable, and in this case is 2. And so if I want to find my axis of symmetry for this one, we would plug in the -4 for b, but it would be -4, and so that would just become a positive, and then 1. And so because those two negatives would just be positive, you'd have 4 over 2, and 4 divided by 2 is 2. And so your axis of symmetry would then be at x equals 2. So then on your graph, you would go ahead, most people will just draw a dotted line for their axis of symmetry. Boop, boop, doop, doo. And keep in mind, this axis of symmetry is also what cuts the parabola in half. And so when you make your table of values, you can plug in the numbers just to make sure you're right, but it allows you to see that it should be a mirror image. But you also use the axis of symmetry so that you can find your vertex. And your vertex, the x value has to be, you take this number and plug it in to find the vertex. And so then you have for now 2 equals 2 squared minus 4 times 2, that's 2. And so then 2 squared is 4, -4 times 2 is -8, and then you would be adding the 2. And so then keeping forward, 4 minus 8 would be -4 plus 2, and then -4 plus 2 would give you -2. And so the nice thing about function notation is it tells you what your x value is always, and then your answer is your y value. So we would have our vertex at 2, -2, and so we come right 2, down 2, just like that. And so then you can use that number to help you make your table of values to finish your parabola. So since my x value was 2, that's going to be my vertex. And then you just want to pick a number 1 on each side of it. So 1 and 0, and then count up 3, 4. And so then you're just going to plug these numbers into that equation and see where it gets you. So if we plug in 0, we would have f of 0 equals 0 squared minus 4 times 0 plus 2. And so then with this, it's always easier when it's 0 because then you end up with 0 minus 0 plus 2, which just gives you a positive 2. And so then at 0, you can go up to 2. And keep in mind, that's also your y-intercept when your x is 0. And you can always find that number if you just kind of cover up your x's in your equation. The number that's left over would be your y-intercept all the time. So then when we plug in 1, get rid of these zeros. What's your question? Is it related to quadratics? Okay. Well, whenever that question comes in, I will be glad to answer it. But when we plug in 1 for this one, 1 squared would give us 1, and then -4 times would give us -4 plus 2. And so then 1 minus 4 is -3, and then plus the 2 would give you -1. And so then plot that point at 1, -1, and just keep in mind that you're staying off of the y-axis. And so we have a nice little curve going on this side. And so hopefully it is a mirror image when we plug in the 3 and the 4. Let me get rid of these numbers. Oops. Okay. So when we plug in 3, we would have 3 squared, which is 9, and then -4 times 3 would be -12, and so then 9 minus 12 is -3, which gives us -1 again. Oops, that's what we plugged in 3. And so then we would be at 3, -1, so we'd come right 3 and down 1, and so far our mirror image is still there. And then we would so I don't want to erase the 4 though. And then 4 squared would be 16, and then -4 times 4 would be -16. And so then 16 minus 16 would be 0, and then 0 plus 2 would give me 2. And so that ends up being the same as well when we plot it, because we would come right 4 and up 2. Oops, missed it. And so you notice with parabolas, it should be a U shape on it. Okay. So moving on to the next one. Let me check in. Okay. So with this next one, we would still be using negative our axis of symmetry because it is a quadratic. And so with that, we want to identify our B and our A and our C. And so in this case, A would be the number in front of the x squared, which is -4. B would be the number in front of the x, which is +4. And C would be the number that is the constant with no x. And so that would be 8 in this case. And so when we are finding the x symmetry, x is going to be -b over 2a. And so b is a +4. And so we would have -4 over 2 times a, which is also -4. And so then we would have -4 over -8 when you multiply those two. And then we can simplify that because we can divide the top and the bottom by -4. And so that would be 1 over +2. And so even though that seems like it might not be the most fun thing to deal with because fractions are sometimes scary, you just have to plot it as best as you can. And it's going to go in the middle between 0 and 1. And it's going to be a vertical line because remember, any line that is x equals is always a vertical line. Okay. And so from there, we would use that and plug it into the quadratic to help us out. So we would use function notation again, and we're plugging in our axis of symmetry number in for x so that we can try and find where our vertex would be. And so we would have -4 times -1/2 squared plus 4 times -1/2 plus 8. And so we would keep that f of -1/2 because that would be plugged in -1/2 for x. And then -1/2 squared would give me +1/4 because if you come off to the side, oops, a negative times a negative gives you a positive, and 2 times 2 would give you 4. So that's how you get 1/4 from that. And then 4 times -1/2, again, come off to the side. 4/1 times -1/2. You know the answer has to be negative because only one of them is negative. And then multiplying straight across, you would have 4 times 1, which is 4, and 1 times 2, which is 2. And so then that would be equal to -2. And so then that would come into the equation like that. And then we'd have the +8. So then -4 times 1/4, the 4s would cancel each other out because this is like it's over 1. And so that would be -1 minus 2 plus 8. And -1 minus 2 would be 3. And then -3 plus 8 would give me 5. And so that would be my vertex when I plug in that -1/2 for the axis, or from the axis of symmetry. So let me come, oops, and I just realized my axis of symmetry is on the wrong side. Oopsie. Since it's -1/2, I need to be on the left side. There we go. That's better. And then I'm going up +5. 1, 2, 3, 4, 5. And you would put your point. Now, because your A is negative, that's what tells you that your graph is flipped upside down. And so this is going to have a maximum. And so when we plug into a table of values, all we're doing is plugging in to that same equation, but we don't have to plug in fractions the entire time. So negative and then negative because those are on both sides of that axis of symmetry. And actually, work smarter, not harder. Use -1/2 as your middle number, and then plug in 0 and 1, and then -1 and -2. So from there, easiest number to plug in would probably be 0, and so we would have -4 times 0 plus 4 times 0 plus 8. And so then we would -4 times 0 is 0, 4 times 0 is still 0, and then we'd be left with 8. So when we plug in 0, we get a +8. Now, if we plug in -1, or no, let's do positive. Oops. When we plug in +1, we have 1 squared, which is 1, times -4, which is -4, and then 4 times 1 is +4, plus 8. And so that is going to give me 0 plus 8. Wait a second. That doesn't work out very nicely. -4 plus 4 is 0, plus 8 is 8. So did I mess up when I plugged in 0? That is strange. Yes, I did mess up when I plugged in 0. Silly me. Because, no. That is strange that when you plug in +1, it still works. We'll come back to that. You're not sure what's happening right now. 0 is +8. Oop. That +1 should be definitely higher. That is strange. Because if we plug in -1, let's see, -1 squared is +1 times -4 is -4, and 4 times -1 would give us another -4 plus 8. And so then this should be -4 minus 4 is -8, plus 8 is 0. And so at -1, it should be at 0. See, I like that number much better. So what is happening with 0? Because the graph should definitely be going down. And so if you can see, sometimes even math people wonder what the heck happened with their numbers. And it happens. So I don't like that one. I do know when I plug in -1, though, it is 0. So am I just having a blind moment? That's very possible. But nobody's correcting me, so we shall see. Oop. Okay. So when we plug in -2, then let's go ahead and skip the 0 for now. -2 squared is a +4, and so then +4 times -4 is -16, and then 4 times -2 gives you -8, and then you have -8 plus 8, and so then -16 minus 8 would give you -24, but then you're adding the 8 back, and so that would give you -16. So then at -2, maybe all the way off of the graph, actually. Okay. And so then plugging in 0, boop, boop, boop. Give me all sorts of funky numbers. Ooh. Too much. But then when we plug in 0, 0 squared would be 0, and 0 times -4 is 0. 4 times 0 is 0, plus 8. This is such a strange graph. Be doing something like that. Ooh, but I cannot draw today. Ooh, that's a bad line. Ooh, there we go. Because when you draw parabolas, you do not want them to be V's, because that's an absolute value graph. But this graph, when you are looking at it, would be increasing. So your domain is going up when the y values are going up like this. Whoop. And then the graph is decreasing when the graph starts going down, as if it's a downhill on a roller coaster, like that. Okay? Okay. So we're going to the next one. This one, our -b over 2a to find our axis of symmetry, is identifying a z first. Oop, I get too excited. But a would be +4, b would be +8, oops, and then c would be -3. And so remember, you do have the advantage with your C, because that tells you where your y-intercept is. And so I know that this graph has to hit at -3. And so then with that, we are going to plug in the b and the a into -b over 2a, that we can find our axis of symmetry. And so that is going to be -8 over 2 times a, which is 4. And so then that would become -8 -1. And so we know that our axis of symmetry is at x equals -1. And so we would come with 1. Oops. And draw our line. Boop. And then we would take that number and plug it in so we could find our vertex. And so that would be 4 times -1 squared plus 8 times -1 minus 3. And so -1 squared is +1 times 4 would give you 4. 8 times -1 is -8, and then minus 3. And so 4 minus 8 is -4, and then minus 3, which would give you -7. And so your vertex would be at -1. And so on your graph, you go left 1 and down 7. Boop, right there. And so since we have this axis of symmetry, we can reflect that y-intercept across the axis of symmetry and make our lives a little bit easier. And so then the nice thing is your y-intercept gave you a value. Your -1 was your vertex. And then at -2, you're going to be at -3 again because you already used that number. And so then you just have to plug in +1 and -3. So if we plug in +1, we would have 4 times 1 squared plus 8 times 1 minus 3. And so 1 squared is 1 times 4 is 4. And then 8 times 1 is 8. And so 8 is 12. And then minus 3 would be 9. And so we'd be at 1, 9 right there. And then if we plug in -3, we should hopefully get the same result. But at -3, we would have -3 squared, which is +9 times 4, and that would give us 36. And then 8 times -3 would be -24. And so then 36 minus 24 is still 12, and then minus 3 is still 9. And so that does reflect nicely over my axis of symmetry. And then you connect it and make sure it's not a V at the bottom as best as you can. Okay, and so talking about the increasing and decreasing, you just have to be careful because when your graph goes up like this is a minimum. Because your y values are going down, and then it's going to be increasing on the right side because your graph is coming up like so. Ooh, that hides the green really badly. We'll use yellow instead. Whoop. Okay. All right. So from there, if we had another one, like 4, we can use the y-intercept to kind of guide our first step if we want to. And then we can also kind of picture, because your A is a +2, that it is going to have a minimum because it's going to open up like that. But our A in this case would be 2, our B would be -8, and our C would be +3. So from there, -b over 2a to get our axis of symmetry. And so in this case, -8 for our b would be a +8 over 2 times 2. And so then that would become 2 times 2 is 4, and 8 divided by 4 is a +2. And so then that means our axis of symmetry is at +2. And so on the graph, we can go ahead and plot that. Like so. And then we know our vertex, we have to plug that in. So then we would have the function at 2 is 2 times 2x, or sorry, 2 squared, minus x would be 8 times 2 plus 3. And so then times would be 4, times 2 would be 8, and then -8 times 2 would be -16 plus 3. And so 8 minus -8, and then -8 plus 3 would be -5. So then my vertex would be at 2, -5. And so I come down to 5. So it's here. And if you want, since you have that axis of symmetry and you know your y-intercept at +3, you can come across and be like that as well. And so then that makes plugging in much easier because you already have some of these. Oops. We know our vertex is at 2, -5. And then we also know that at 0, it is at 3. And at 4, it is also. So when we plug in 1, we would have f of 1 is 1 squared minus 8 times 1 plus 3. And so 1 squared is 1 times 2 is 2. -8 times 1 is -8 plus 3. And so 2 minus 8 is -6 plus 3, which would give us -3. And so then, wait, not -3. See, because at 3, 1, 2, 3. Oh, yes, sorry. Had a brain fart for a second. And then oops, I put the wrong one. But regardless, even when I plug in 3, I should still get the same result, but we can double check that. Because when we plug in 3 minus 3 is -24, and then 18 minus 24 still gives me -6 plus 3, and so that's going to be on the so. Okay. Alrighty. So I'm bugged by the other question that I did not figure out why it was working out nicely because it should have been. So I'm thinking that it was something to do with my axis of symmetry. So I'm going to force myself to come back because we must. Our axis of -b would be -4 over 2 times -4. Oh, it's a +1/2. Goodness. See? This is so with that, I don't know what negative came, but we should regraph. Okay. But since it is +1/2, means that 1 and +1/2, 1/2 squared is still a +1/4. So -4 times 1/4 would be -1, and then +4 times +1/2 would be +2. And so then -1 plus 2 would be +1, and then 1 plus 8 would be 9. There we go. That's better. Okay. So axis of symmetry is at +1/2. And vertex is at +9. So then when we ignore our other x's, we can tell that our y-intercept is supposed to be at +8, which makes sense on why I was getting 8 when I plugged in 0. See, this is why you have to be careful. Because even I mess up, unfortunately. But doing this, now it all makes much more sense. So just in case you want to verify it with the +1, squared -4 is -4, and then 4 times 4 is 4 plus 8. So that does indeed work out to be +8 again. Okay. So from would have we would want to plug in +2 and probably -1. And so if we plugged in +2 first, just because I would prefer to deal with positive numbers, 2 squared is 4, and 4 times -4 would give me -16. And then +4 times +2 would be +8. And then we'd have that +8 again. And so -16 plus 8 would end up giving me 0. And so at 2, I'm touching the x-axis. And so then if I plug in -1, do this real quick. -1, -1, -1. -1 squared is +1. +1 times -4 is -4. 4 times -4 is -4. And then we'd have the +8. And so -4 plus -4 would give us 0. +8 would give us another 0. So it would be right there. Oops, and I did not put this one. And so this is what the graph should actually look like. Glad I was able to find that. Whoop. Okay. So it has been about 30 minutes. I haven't gotten any questions yet. So I know this e-learning, nobody wants to come to school. It happens though. Oh, but I think someone just kind of schooled you one, so we'll see. Hello. What's your question? Okay. You can type your question out though. Oh, there it is. Now it says you're typing. You mean more like the one that is on the screen right now? Okay. Easy enough. Have you seen any of the other ones yet? Okay, no worries. But when you're doing these, you always want to start by finding your axis of symmetry. And so to do that, you're going to have to do the negative b over 2a. And so with this one, at least, your a would be the number in front of the x squared. So that would be +1. The b would be the number in front of the x. So that'd be -5. And then the c would be at +6. Because that's your number, that's your constant. And so because of that, the nice thing about your constant is that that's also your y-intercept. And so you can do them both at the same time if you want, and just go ahead and plot that point. So that's at +6, so it should be up here. And then since your a is positive, we should expect this graph to kind of look like this. So all of this just kind of helps lead up to your axis of symmetry, because when you plug this in, then you can kind of get an idea of what it all will look like. So when you plug in the negative b, that would be positive 5. And so then over 2 times 1, because you're just plugging in the a and the b. And so that would be 5 over 2. Ooh, that one does not work out very nicely, does it? No, it does not, but it is okay. So then 5 over 2, that would be 2.5, I think. Let me double check. Yep. And so then on your graph, that would just give you your approximate, or your actual axis of symmetry, not approximate. And so then you take that number and you plug it into the equation itself, which most of the ones you're getting probably already have the y equals, or they have f of x, because remember, f of x just replaces your y. But then you're going to plug in your axis of symmetry number in for your x, so that you can figure out what the y value is of your vertex. So you'd have 2.5 squared minus 5 times 2.5 plus 6. And then you just be one step at a time working through it. So then 2.5 squared is 6.25. And then negative 5 times 2.5 is 12.5. So then 6.25 minus 12.5 plus 6 would give us, which this one does not work out nicely at all, but it is negative 0.25, which is a negative 1/4. And I will say we probably won't give you such ugly ones to graph like this. This would probably one you'd rather graph by factoring, but we haven't gotten there yet. But then you would be about negative 1/4 underneath. And again, you're just kind of estimating to the best of your ability. Yeah, so if your b is positive, then it would be negative in the equation. But since in this equation my b is already negative, then it became a positive. So then, since we have our vertex at 2.5, we can do the rest of the graph just based off of the fact that we know that's our middle, but we can pick easier numbers to deal with. So numbers just directly close to 2.5 would obviously be 2, 1, and 3, and 4. And so then you would just go ahead and plug that into the equation. I'm going to separate these, but you're just going to plug that into the original equation again. So f of 2 would be 2 squared minus 5 times 2 plus 6. And so then 2 squared is 4, negative 5 times 2 is negative 10, and then plus 6. And then 4 minus 10 would give us negative 6 plus 6, which would just be 0. And so then at 2, we'd be at 0. And so we should, when we plug in 3, get the same result. So I have a tendency to just like to plug in those numbers because I can make sure I did it right the first time. Come on. I don't know why it doesn't want to erase. There it goes. But when you plug in 3, 3 squared is 9. Negative 5 times 3 is negative 15. And 9 minus 15 is still negative 6. So we still get 0 at positive 3 as well. And so then at 1, it should still be below our y-intercept. Boop, boop, boop. And so 1 squared is positive 1, and negative 5 times 1 is negative 5. And so then 1 minus 5 would be negative 4. And so negative 4 plus 6 would give us a positive 2. And so at 1, we'd be at positive 2. And then at 4, Again, you just kind of have to plug them in one at a time, which I know is sometimes obnoxious, but you can do it. But when you plug in, 4 squared would be 16, and then -5 times 4 would be -20. And so then 16 minus 20 would be -4 again, and that would give us +2 again. And so then 4 up 2, and then you can draw your parabola. You don't have to reflect the y-intercept every time, but if I can graph it, I generally do just for the sake of doing it. But then you can and draw your parabola like that. But finding your axis of symmetry is the big thing, because that's what kind of guides you in what numbers to plug in for the rest of the parabola. And then you're just plugging into the function itself. And then if you wanted to take it a step farther, just identifying the parts, you would have a minimum in this case because it has a low point. Minimum. Oh, goodness. And then with this function would be decreasing from the left side up to that minimum point, and then increasing from the right side on, because your graph is going up and to the right for those increasing and decreasing. Oops. Trying to write it on there, but ooh. Okay. But that's kind of the broad overview of these functions. But I'm probably going to end the YouTube live stream just because I've been on for like 30 minutes. Do you have any other questions, though? Okay. And if needed, I can send you the link to the YouTube video as well. You are most welcome anytime. Happy to help. All right, I'm going to be signing off for now, but we will be back on at 2 o'clock this afternoon for Algebra 1. Probably going to do more stuff with quadratics, but we're going to be ending the YouTube live stream now, so we will see you all later.